let's look at these together. There's a very simple question here. Okay, 2y equals x minus 1 and 3 and y equal 2x minus 5. Okay, you see, this is a simultaneous equation problem. And we are required to solve this question using a graphical method. You know, we've got the substitution method, we've got elimination method, and even use matrix to do this. All right. But then, how does this graph method work? The most important thing is, from equations of straight lines, we know that y equals mx plus c is a general equation for straight lines. And if you compare these to these equations, you see that these equations are actually equations of straight lines. All we need to do is figure out these straight lines. Okay, how do we figure them out? To get a straight line, all you need is 2 points. If you get 2 points, and then you have a ruler to join those 2 points, you have a straight line. So we need to find out 2 points for this equation. Connect those 2 points with a ruler, we'll have a straight line. We'll get 2 points for this second equation. Connect it with a ruler, we'll have another straight line. So now we'll have 2 straight lines, okay? And they're supposed to meet somewhere if they have a simultaneous solution. That is, if they have a solution that is correct for the both of them at the same time, they're supposed to meet somewhere. And then when they meet somewhere, we trace the point where they meet. That's our solution for the simultaneous equation. Okay, so let's do that. This is how you do it. First step, get 2 points. Let's start with 2y equals x minus 1. To get 2 points, we need to just get a random value for x and then solve for a random value for y. Okay, just any random value. But I've got some limitations here. You see, my graph sheet is in whole numbers and my scale is 1:1. So I don't want to have decimals or anything like that. I don't want to have numbers beyond what I have here already. Okay, so I'll be looking at numbers that will fall within this range here. Okay, to achieve that, I will use small numbers that will be whole numbers. All right, so for this, let's assume x is minus 3. I'm calculating that if I take minus 3, I will have an even number. So I will divide and get, a whole number. So minus 3 minus 1 over 2. That's how to find y. This is minus 4 over 2, and that is minus 2. So I'll have a small table here. I'll put x first and then y. I assumed x to be minus 3, just a random number. Any number can do it. All right? And then I solved and found out that my y is minus 2. That is minus 3 minus 1 minus 4. Minus 4 divided by 2 minus 2. So minus 2 here. All right. I have to do that again. Remember I said I need at least 2 lines. You can't do this with just 1 line. You need 2 points, you can't do this with just 1 point. You need 2 points to get a straight line. All right. I'm going to think of something else. If I use minus 1, I'll also have an even number. So minus 1, that's minus 2 over 2. Wow, it works. So minus 1 and minus 1. Plus minus 2 over 2 is minus 1. So I have 2 points for the first equation. Easy. Let's go to the second equation. Okay, take that out. For the second equation, we have y equals 2x minus 5. Okay, if I use any number here, it will just work because I don't need to divide. Okay, if I use 3 here, 3 times 2 is 6. The 6 minus 5 is 1, right? Okay, another table for this, x and y. Now for x, I just used 3. All right, that is why I had 3 times 2, 6. So I'll say when x is 3, y will go 1, 1. I'll do that again. Think of another number. Let me use minus 3. If I use minus 3, 2 times minus 3, I'll have minus 6. Minus 6 minus 5. Let's see. Minus 6 minus 5 is minus 11. Do I have up to minus 11 on my y-axis? Nah, that's too much. I need to come down. Okay, what if I use 0 as my x? So if I use 0 times 2, 0 minus 5, all right. So You see, I've got those limitations of making sure I use figures that I have here. But you can use that minus 11 if you have a bigger graph sheet, and so this will just work fine. All right. So I'll use 0 because of my limitation. 2 times 0 minus 5. This is actually 0. So we have 0 minus 5. Y is minus 5. So I will use 0 and minus 5. Okay, I've got 2 points for each of the lines. Now, let's get started with plotting it. For the first one, the first line, when x is minus 3, y is minus 2. So on the x-axis, this is minus 3. Y-axis down here, minus 2. I'll make a dot there. Okay. When x is minus 1, y is minus 1. X is minus 1, y is minus 1. I'll make a dot here. Okay. All right. I'm going to rule that. Let's see. Too big. All right. Make it a little smaller. Done that the right way. Okay. Bring it closer. Bring it closer. Okay. Let's see. Okay. Closer. Wow. That looks perfect already. Am I sure this is perfect? All right. Let's go ahead. Okay. Oh, that's near perfect. All right. Let's plot the second one. When x is 3, y is 1. X is 3, y is 1. I think that should be somewhere here. Here. No. This is y minus 1. X is 3, y is 1. That should be somewhere here. And then x is 0, y is minus 5. That should be somewhere. Okay, so we'll get this again. All right, make that smaller, and then we'll turn it the right way. Bring it closer. Okay, so let's align that properly. Okay. All right. I think that is near perfect. Okay. All right, let's rule that now. All right. Now, you see there's a meeting point here. The meeting point is here. See that? There's a meeting point there. So we trace the meeting point down. Let's find out what we're going to get on the x-axis. On the x-axis, the meeting point is perfectly at 3. All right, I probably need a sharper color. So 3. And then on the y-axis, it is perfectly at 1. So you see, x equals 3, y equals 1. You could have told this already from, let's see, that. Just simply tell.